Hi there. I'm going to be showing you how to find the derivative of a function of the form f of x to the g of x. So one function to another function. This does work if g of x is a constant, but that's just the power rule, which is very easy. This can also be used to prove the power rule, but we'll get into that later. So, to do this, we're going to need to know several things. Excuse me. The first couple are log rules and then derivative rules. So, we're going to need to know that you can rewrite x as ln to the e of x as well as e to the ln of x. This is the one we're going to be using. We're also going to need to know ln of x to the y, so that y is supposed to be an exponent, equals y to the ln of x. This works for any other logarithms. This is just log base e. So log base 10, which is usually just log with no subscript, no base, then it would still be log of x, or y times log of x. There we are. I can speak properly. Next, finally, we're just going to need to know some of the derivative rules, which hopefully you do. So, product rule, derivative of two functions being multiplied is one of them times the other's derivative plus the first's derivative times the other's, just the other. Need to know the derivative of ln of x, just 1 over x. Derivative of e to the x is e to the x. And the derivative of f of g of a composite function, so one function inside of the other, is the derivative of the first with respect to the inner function times the derivative of the inner function itself. Of course, if there are multiple functions being multiplied or multiple inside of others, you're just going to have to keep using the chain or the product or even the quotient rule if that were involved. Now, knowing all those, we can start deriving our function. So, the derivative of f of x to the g of x. We're going to want to rewrite f of x to the g of x using some of those log rules. So first, we're going to want e to the ln, and this whole thing is going to be in the natural log. So ln of f of x to the g of x. Using another log rule, we can change this to e to the g of x times ln of f of x. So this is the form we're going to use, because this we can actually derive. We don't have a general rule for a function to another function. So that's what we'll use. d dx of e to the g of x times ln of f of x. Now, using the chain rule, the first step is to get the derivative of e to this, which is, of course, e to that. So, e to the g of x times ln of f of x. Now we want to take the derivative of this in here, which uses the product rule. So this is going to be multiplied by the whole thing, so it's e to all this times the quantity, g of the derivative of this, which we'll start with g of x, and then we derive ln of f of x, which is going to use the chain rule again because it's a function inside of another function. F of x is inside of ln, not the natural log. So, first the derivative of the outermost function, so ln of f of x, which is 1 over f of x, times the derivative of the inner function, which is f of x, which is just f prime of x. And we add, because this is still the product rule, we found this, so then we add g prime of x, because now we're taking the derivative of the first part of the product rule function, times, we leave this one alone, so that just stays ln of f of x. So that's a correct answer, but we can definitely simplify this. So this up here, we can just go backwards in steps from here. So this goes back to this. Well, we can see the steps here. So that all just becomes f of x to the g of x. Now, all that is being multiplied by the quantity g of x times f prime of x over f of x plus g prime of x times natural log of f of x. So this is the simplest form we have. I don't recommend memorizing the form like all the other rules. Or if you don't memorize those, then congrats. I think it's more important to memorize, or at least to have the intuition to find the steps of going e to the ln of the whole thing. That's probably the most helpful, because this is just really long and not fun to memorize. So let's go for an example. Keep it pretty simple. We'll just use cosine of x. Excuse me. Cosine of x to the sine of x. Just a couple of trig functions, because those are simple enough and show what I want to show. So, finding the derivative of them, we first change this so it is e to the ln cosine of x to the sine of x. Can rewrite that as e to the sine of x to the times the natural log cosine of x. So that's what we will use. d dx of e to the sine of x times natural log cosine of x. So the first step is e to that, which is just e to that. This is using the chain rule, of course. Sine of x ln cosine of x. Then the next step in the chain rule is to multiply by the derivative of the exponent here. And of course the exponent is a product of functions, so we're using the product rule, and it's being multiplied, this e to all that is being multiplied by the quantity of it. So sine of x remains undifferentiated, and we're deriving ln of cosine of x, which is 1 over cosine of x times the derivative of cosine of x, which is minus sine of x. We don't want that second in the parentheses. There we are. So from here, we add the reverse. So derivative of sine of x is cosine of x. Then we leave the other one underived. So natural log cosine of x. Now with that done, we can simplify. E sine of x times natural log cosine of x. We can just revert it back to our original starting point. So cosine of x to the sine of x times the quantity. Sine of x cosine of x times negative sine of x. One of these can go over the cosine and we'll get negative tangent of x times sine of x plus cosine of x times natural log cosine of x. So that's the simplest one. And if we look, it does match what it would have been if we just went 1 for 1. Reversed g of x and f prime of x over f of x here. And otherwise it is exactly the same. Now, like I mentioned, you can use this to prove just the base power rule where the g of x would be a constant. So let's do that really quick. There we go. So f of x to the n. We know it's just a number, so we can use the power rule if we wanted to, or it would be n minus 1, or n times f of x to... Never mind. I'm getting all flustered. Okay, so using the same method, we're going to change it to e to the ln of f of x to the n. And e to the n times ln of f of x. Now, the derivative of e to the n times the natural log of f of x follows the steps we did 2 times that. So e to the n times ln of f of x times the quantity. We will leave n as it is and take the derivative of here, which is 1 over f of x. We don't even need that one, because we know what's going to happen to the f of x. It becomes f prime of x. Now the second part of the product rule, which is here, we would need to take the derivative of n, which is a constant. So any constant's derivative is just 0, so the second part of the term just goes away. So we can stop there. E to the ln of all that turns back into f of x to the n. And it's being multiplied by n times f prime of x over f of x. Another way of writing this is f of x to the n times f prime of x all over f of x. Well, these are going to cancel out, or at least this is going to drop down a level, so n becomes n minus 1. So now we have f of x to the n minus 1 times n times f prime of x. For the normal power rule, f of x is always just x. So if that's the case, f prime of x becomes 1. So if f of x, oops, oh dear. Okay, good enough. If f of x equals x, then it is x to the n minus 1 times n, and then the derivative of x is just 1. Another way of writing that, n, n times x to the n minus 1, which should look very familiar. Hopefully this helped, because I have not seen this anywhere online really. I've seen videos and descriptions of what is called the general power rule, but that's not this, and I think it should be. But I never learned the general power rule in the calculus class I took. Hopefully, though, if it does exist, I apologize, but hopefully this helps someone like it helped me.